I'm going to tell you something about a project I'm currently involved in, and the theme is context-driven search ranking and faceting. So a little thing about me, I'm the CTO of the shopping24 internet group, which nobody will know in the room except Toby, which is my colleague. That's okay. We're part of the auto group, which some people may know it's the second largest retailer in Germany, and I made this journey to come here to Vegas. And yeah, I drive my road bike and do some landscape photographs. What is shopping24 doing? We're an e-commerce product search. So we don't sell anything. That's the hardest part of the business. So what we buy users from Google, when you search for address at Google, we're at #1 in the AdWords ranking. We buy you, we pay Google for the click, and we present you about 60 million dresses or t-shirts or whatever you want. And we get paid by the click to the shop. So you buy at the shop, not at our website. We're just the scam in the middle, basically. So another thing that we do is that we present related products on third-party websites. And that can be any kind of third-party website. It can be an e-commerce website, like a fourth or fifth largest retailer in Germany. Or it could be a cooking site. So you have a recipe for cooking whatever, pancakes, and we present the products matching to those pancakes. Yeah, what we do, our software stack is fully open source. The only thing we pay for is the VMware license, which is going to expire in about a year, and everything else is open source. We're very committed to open source. We contribute actively to various projects and maintain some smaller solar plugins ourselves. And yeah, that's the zoo we're maintaining actively. A little history is we're now 10 years live on Apache Solar. And search evolved from, we started at version 1.3, and search evolved through the time. And we're now running something 6.6 or 6.5 or something. And the funny thing is that we built lots of features for Solar, which then got included in Solar. Not our code, but alternative versions got included into Solar. So we wrote a lot of plugins, and we disposed a lot of plugins, and we threw them away. And yeah, it's been a fun and whirlwind tour with Solar so far. So what we're running is a pretty highly customized Solar. This is the default search components we're running through on every search. And we have components for doing a better more like this, for deriving facets, for doing boost terms, for extracting boost terms, for doing semantic search, and whatever. So we dug through that code a lot. And I promised an advanced talk and a deep dive, and I try to show not that many code, but I'm gonna give you ideas on how to implement context-specific searches and how to build context into your search. Yeah, we compiled a directory for Solar plugins. That's the advertisement here. I found that solar.cool was free, so I registered solar.cool, and all the plugins we tried, we evaluated, are listed there. So if you're looking for plugins for Solar, try solar.cool. We're looking for contributions as a GitHub project. It's open source, so just shoot your pull request, and we're happy to add it. All the folks interested in Solar plugins, maybe on that side or that side, I don't know where Jan's talk is about Solar plugins, but if you're going to miss that, that might be a good source for Solar plugins. So that's the motivation. Why am I standing here? And the first thing when I talk to my colleagues or some clients in the auto groups or other companies in the auto group, the first thing I say is search is contextless. Don't ever assume you know the context of search, because because some user is in a category like dresses and he types in a search, don't assume that he searches or want to refine his dresses search. Most of the time maybe he's looking for a washing machine. So always assume that search is contextless. And we have been working with some other companies in the auto group to make the task to make search context aware. I'm going through some context in the next slides, but context awareness is pretty important in all terms of search, to understand user intent, to know what the user is really searching, and how to really lift your search results, to improve conversion rates, click-through rates, and all the other things. The most important context is personalization. The personal context is the most important context. We all have our own, very own filter bubble, and we want to live in that filter bubble. It feels cozy, and we all have our favorite brands in e-commerce, and we know what we want if we search for a t-shirt. I want larger size of t-shirts, men's t-shirts, and that's the most important context. That's a hard task, because you need to gather data, you need to push it into your search, into your Solr instance, but that's something that you're going to do up front. You're going to collect the data outside, you maybe train a model, but you're pushing the data into the Solr from an external API or your website. That's usually not something you have built or baked into your Solr. Another interesting context is the conversational context. Chatbots are everywhere. It's the new hot thing, beyond touch. And I tried it out. I'm not the chatbot type of guy, but I was really impressed. I tried the Chat Shopper chatbot, and it really delivered jeans in black. And the fun part is the application understands context switches. So I searched for jeans for myself, then I wanted a dress for my wife, and they were not in jeans color or black color. So that's a pretty fun tool to try out. And conversational context on the other side is something you don't want to bake into your search engine as well. It's something you handle before you will have an API in your chat application, and you're going to do the natural language processing there. If you build an Alexa skill, you get delivered the intent that Alexa extracts from the spoken input, and you're going to build a search phrase or search query and a filtered search query around that. The next thing, and that's the one we're going to focus on, is the category context. So that's a really, really bad search example for a television. And television is going to follow us through the next slides, the search for television. Because we have a lot of products, and we have all kinds of categories. So we have home, we have accessories, we have Technic, we have clothing, everything, about 60 million products. And if you search for television, and you do a completely unboosted and unranked search, this is about this is the thing that is going to show up. You have like accessory for TV, you have TV, you will have TV low boards, you will have t-shirts with a TV on it, you will have everything in TV that has the term TV or television or whatever your synonym is in the title or in the description. So the task that we had was that we wanted to detect what is the context of the query that the user is searching. So you type a search, and we want to know what is the context, and we wanted to do that. We did not want to do it up front. So there's one thing that you can do. You have the user query. You throw it at some machine learning algorithms, and you get a percentage. What is the category going to be that this query is falling into? But yeah, so you come from a query to a category. There was a talk last year at Solr Revolution. It was pretty good. That I think Target was presenting share their knowledge about exact that thing, doing it with machine learning, and the results were stunning, and they could even fill some zero result pages with the results from those machine learning algorithms. But there are challenges. One thing is, that's a pretty German joke, you have ambitious queries. So there is a brand called Brown, which sells shavers, and you have the color brown, obviously. And if someone just searches for brown, what is he really looking for? Is he looking for anything brown or some furniture, or is he looking for a shaver? What's he up to? That's difficult to learn beforehand. You have a certain percentage that it might be a shaver, or it might be home or furniture or whatever, or a dress in brown, but you cannot be sure. You have trending queries, you have new queries. We had on Shark Tank, on the German version of Shark Tank, we had a kid's beanie from ThinKid. We had no idea what it was, but it sold through the roof on a weekend. And we did not know the query, and we didn't have any boost terms, we didn't have any special handling for it, so we presented a pretty shitty result. The customers bought anyway. That was a good thing. So in the end, nobody wants to configure an infinite amount of queries. You can do it by hand, you can do it by machine learning, but those approaches will always leave you with the top percentage of queries, or with the top percentage, or a certain percentage of confidence that the machine learning algorithm will give you. So what we wanted was, we had, let's say, an interesting customer where the category managers were not really, it's a big e-commerce site inside the Otto Group where we are supporting them and getting onboarding to Solar, and they were not really ready for this, say, deterministic or non-deterministic approach of machine learning, or any type of manual input of queries. So they wanted a deterministic result. Each query has to be context or category context detected, and it should be at about 100% coverage of the queries. So that was the task we had to fulfill. There was these small side things, do it in a 1-digit millisecond time, make it highly configurable, do it in a Solar Cloud mode, reload instantly, and make it all measurable. And clutter metrics all over the thing. And yeah, do it fast. We want to go live. So I'm going through some tasks that we fulfilled on that project journey. And the first task was, okay, let's go. How can we detect category context through the current search result inspection? We didn't want to find a second query. So what you can do is that you have a query for television, you fire it at Solar, you look at facets, you look at distribution of documents, and then you know where the query is going to fall into, and then you fire the real query with some boostings. But we wanted to do it on the fly. So what we wanted to do is the query enters the Solar, and some magic thing inside will detect what the category context is and will adjust things inside Solar. So that was the task. And first thing we did, if you have any questions, please ask them on the fly. Or if I speak too fast or something, just slow me down. First thing we did was, okay, we have to define those category contexts. What we did was, we defined category context as Solar queries. They're Boolean or term queries. They're pretty easy. There are 3 examples. We have electronics is the assortment. Electronics, we have TV and TV furniture. Those are all made up, by the way. No real examples, but it could be. So we put them into JSON. JSON is easily uploadable into Zookeeper, where we stored those contexts, and can be from a back office website or whatever the shop has. We can upload things into Zookeeper. And what we did then was that we loaded, it's an easy task. You load the JSON of Zookeeper in your new or first searcher event. And what we wanted was that we wanted to represent the context or the search result of each context as a bit set. You fire all the searches you define, or context definitions, you fire them against your current index, retrieve the bit set, and store it. So you have all your context definitions, you have a name, you have a query, and you have the result of those queries as a representation over your current documents. Then it would be an easy task to just run your query against those bit sets and look where the matches or where the overlappings are the biggest. So if you should not know, bit sets are fun. That's pretty easy. That's the most important thing. Everything you do with bit sets is fun because they are fast. They're in Solr, they represent for each document ID, they represent a Boolean. And each document is either included in the result set or in the bit set or not. So they're fast. You can do all the funny operations, the AND, the XOR, the whatever, and they do it in 0 or 1 digit millisecond time. Even for larger indexes like ours is, with 60 million documents, it's a pretty easy computation, and it's pretty fast. So how do they work? In Solr, you have the documents lined up from 1 to max doc, the documents in Solr. And for each document, you have a projection to 1 or 0, or to Boolean false or true. And in this example, you have the TV, where the document ID 1 is not included, and the 2 is included, the 3 is included, and so on and so on. And you have the low board, where you can guess it, it's only 3, 4, and 5 that is included in the search result for low board. So, yeah, and you can guess, whoopsie. You can do the computation now. You can do an AND or an XOR or whatever to retrieve overlappings, to retrieve exclusions, what is inside, what is outside the context, and how big are the results. So what we did was we have our context definitions. Those are the above 3, so it's shifted 90 degrees. You have the doc IDs from 1 to max doc. You have the context for TV, electronics, and this time it's home or something. And you have a query. And what you can do now is you can just do an easy AND computation on the bit sets. So the query LED TV will fall into context TV or electronics. You can then it's up to your business needs or definitions what you do with those overlapping contexts. You have an electronic context that is pretty big. You have a TV context that is more narrow. And you have a query like LED TV that falls into both contexts. A very easy approach is to take the more narrow context, or you could look up how big is the coverage of your current query in your context in percentage, or how much does your query live outside of the current context. That's really up to a business decision, but you can do a lot of math with it, have a lot of fun with the formulas, and it's a good task. If you want to implement it, you are going to have some fun with Solr, because what you want to do is build a collector. You want to build a post filter. Post filter in Solr is applied after documents are retrieved from the index. You want to do it right after index retrieval, because that's a thing you want to decide on the context pretty early in the retrieval path. So in order to build a collector, which gets notified of all the documents matching for the current query, you have to build a post filter. In order to install a post filter, you have to build a QParser plugin. And the call hierarchy in my very great drawing skills is you install a context queue parser plugin into your Solar. It's pretty easy packageable. That's the good thing. You all put everything in a jar file, and that's it, and fire it up and configure it. The context queue parser plugin creates a parser that, in this case, is a context post filter that is inheriting from the abstract post filter. The post filter is asked for the collector at some times. It's a pattern that goes through Solar that you often have hulls of classes that just delegate to the next level. And all your implementations are pretty sparse, and the only thing that matters in here is the collector at the end. We implemented a context delegating collector, and the calling pattern for that collector is that it gets called, the collect method gets called for every document in the result set in ascending order. Beforehand, if a scorer is present, the scorer is set into the collector. And if you're lucky, and in the main query, you get to call, the finish method gets to be called at the end of the processing. Side note, it's not going to be called in any collapse component, so because that's not a way of a delegating collector. But fun part, you can collect all documents, you can build your own bit set. Upon finish, you can do your context matching, and you have your context. So that's a pretty rough prototype, but it's working. And that's how I really like to work. And that was the result of the really rough prototype. With lots of debug, we have the query, Fernseher is television in German. And we have context considered, like electronics, TV furniture, and televisions. And it elected the television query category context for further processing. So what I mentioned earlier was you have to think about collisions, the big, small, narrow context thing. What if TV is a very ugly example, because if we search for television and you do the context computation on the full search result, half of it falls into home and furniture, and half falls into electronics. So that's again a business decision. What does it fall into? What do you prefer? And that's a pretty unpretty example, but that's the real life. Yeah. So that's an example of the query TV, the context television, and the context electronics. That was the other thing, the narrow context and the broader context. And another example would be the query TV, the context television, and this time it's TV low boards. People love to put their TV on low boards. I don't own a TV, so I don't know, but they put their TV on low boards. It's pretty popular, so half of the result will be TV low boards, and the other half will be the TV thing. You have to handle that, but business decision. Yeah. Next thing, faceting. You have detected a context. Congratulations. As we learned in the talk before, no balloons are going to fall out of the ceiling. You have successfully detected a context. Now what to do with it? Next thing we're going to do, we want to do faceting depending on the context whether we detect it. So for electronics, you have other facets than for home and furniture, or for apparel, or for whatever. So we follow a simple schema, put everything into that JSON file, define for each context, define the facets you want to retrieve, and load them. When you load the context definition from Zookeeper, store it in your plugin. You have a context detected, and then apply them. How to apply them? It's when we build Solar plugins, we always follow a pretty easy and dead simple approach. What we do, we think that the plugins in Solar do a pretty awesome job. They just need to be configured right, and they need to be configured on the fly. So what we build components that configure other components. In Solr, you can configure the order of components running a search query, and we often have configuring components or deriving components or whatever. So when we, oh, this is going to be tough. When we detect a context, we store it into the, you have like a storage for everything in the request. You can just store your detected context as a domain value object. Pull it out in your component as you have the request or the reference to a request, and then just enumerate the facets, configure the facet component that is running after it, and you have your facets for your context. Perfectly easy, and about 1 hour of work when you write the test. So that's the fun part. Apply ranking depending on the category context. What we do is that we apply different boost functions depending on the context that we detected. And so we configure them in the JSON, load them up to Zookeeper, read them when we read them out when we load the thing. And the easy task is that you need to break all the scoring to change the scoring, and just to it's like doing magic to Solr. And so we're deferring delegation. I said that we have a delegating collector, and what we do is that we don't delegate. We're the asshole in the middle that just don't delegate the collect calls. We just collect all the documents, we decide on the context, and then we delegate. Because what we want is to change the scorer. That's the call timeline. In the context delegating collector, you get a scorer injected. You get collected with all the document IDs. You get finish gets called. You decide on the context. Then you delegate the set scorer method, and you change the scorer. We wrap the scorer with a boost function so that the delegating collector that comes after us will compute different scores. Then we store the collected documents, and we just replay them, call finish, everything is fine. And that's a pretty easy task. Yeah, some insights. I mean, writing a scorer sounds complicated, is easy, as you can just extend just a simple method. In this case, we wrote a scorer with and multiplied it with a boost, because in this case we had a boost function. You can, just like we transformed the query in the defining context query, category context query, into a bit set, you can transform the boost or the BF function you define. You can transform it into a product value function or value function and apply that on each document ID. So I need to speak up a little, and that's the next thing to do. That was not the very fastest implementation, because we have to go through all the search result, which could be about 1.9 million documents for, let's say, T-shirt. So what does the good computer science guy do? Whoa, let's use a buffer. And if you're a really good computer science guy, then you use a buffer and you do some sampling on the documents that you're collecting. You're not considering all documents in your bit set operations. Just consider some of them, or the first ones, or just sample them when you fill a buffer. That's a huge speed up because you can compute smaller bit sets if you're not leveraging the full max doc set bit set length. You can just do the operations on smaller, or compute smaller bit sets and do the operations on smaller bit sets. If you implement a buffer, make it configurable so you can play around, make it bounded, and in the call line, the thing that changes is that you collect your doc IDs, and until the buffer is full or your search result is or finish gets called, and then you decide on the context, then you replay, and then you set the scorer, the wrap scorer, then you replay, then you're done, and every document that follows upon a full buffer gets a direct delegation to to the next delegate. So what I learned from Bloomberg are those 4 points. Make it, what was it? Make it work, make it fast, make it stable, and make it better. And we're right in the middle of make it stable and make it better. And that's the big task we're going to do now. So I sped through the last slides. The result is, I don't know where this is from. It's just perfect. Context is important. It can be computed deterministic. You have to just fiddle around some business things on those collisions. Solr is, if you know what you're doing, Solr is pretty easy, extendable. You can plug in. Just don't be afraid of plugging in any collectors, plugins, or whatever. You will fail, but you will learn. So we learned that Solr is a heap-eating monster if you deploy custom code, but you just need to refine and debug and find your memory leaks. So we managed to define a context, detect a context. We could change the ranking function. We managed to do facets depending on the context. So now it's up to you. Use your imagination. You can do anything what you want with a context. You can refine queries. You can apply other boost functions. You can do personalization depending on a context. So from that point, then it's fun. So thank you. Any questions? Yes? The question was if there's no context defined. On the one side, you could leave it to business, or have some general context defined, some backup context. That is a match all query. Then you always have a matching context.
JSON files that you input into Zookeeper, those are maintained by, or is it?
They are maintained in the back office. You have a shop back office that produces the JSON file and just uploads it to Zookeeper. And you can install on the new first search event, you can install a watcher on that file. So as soon as it changes, you can reload your context definitions.
How do you handle a scenario where I'm browsing the category through navigation, like say women's, but I'm searching for a TV in the search bar?
Yeah. The question was, how do we handle browsing or category browsing things? We like to see category browsing and search as the same thing. You have a set of documents that represent your current search result. It's, we don't distinguish between search and category browsing. You can do the same algorithms when collecting those documents.
So you talked about the ranking order side. Every query has different result sets. So how do you optimize that order size? Like t-shirt, you said 1.9 million. Something more specific would have a much smaller.
Yeah. The question was how we define the buffer length of the, yeah. It depends on your installation, on your result, on your average result size. For the client that we built, a buffer of, I think, 4,000 or 8,000 documents was perfect. It depends on your presentation. If you have like indexed on a SKU level or on a product level. So you have to just fiddle around with it. There is a you can do it statistically. There is a relevance point where a bigger buffer doesn't get any better than the ones you have. So no more. Oh, one last one.
So I understand that here you're trying to determine the context programmatically, right? Have you guys experimented with asking the user, like what category would he prefer? For example, TV, you have to search on TV, electronics, home. Just ask the user, which category is he interested in. Has that worked?
It would be, the question was, why don't we ask the user? So I think it would be a great approach for getting feedback on the computation. But I think the user just wants to buy stuff. They don't want to improve our search. So I wouldn't rely on user feedback. And most of the time, we implemented user feedback. You tend to get the bad feedback only. No one is gonna, there are no balloons falling from the ceiling. You could present the filters more prominently and go left or right. Yeah, that would be an approach. Yeah. Okay, I'll be around. Follow me on Twitter or talk to me on Twitter, write me on Twitter, whatever. Thank you.